Hello everyone. This session is about the bio and the multi-queue layer. This is part one of the session which discusses about the bio layer, and we're gonna have another session video which is gonna be discussing about the multi-queue layer. Since this is a big topic, I've split this into two different videos, so it'll be easier and short and sweet for people to watch, right? So this is the agenda for the session video. The first one, which is this, we'll be discussing the bio layer. We'll start with a little bit of accounting that the bio layer does for which parameters. Then we're going to move on to the different types of block devices, request based and bio based, and the code path the bio takes for each of them. And then we're going to discuss recursion avoidance, how it can occur, and what and how the code is written to avoid recursion avoidance, right? So the second part of this session would be in the second video, which will discuss the multi-queue layer. So let's get started with the bio layer. Right, so in the bio layer, the unit representing an IO in this layer is struct bio. Among the members of the structure, the most important one is the list of bio underscore vecs. Right, so each bio vec holds a range of physical address pages. These are the pages which are mapped to the virtual address of the buffer passed by the user. The list hence make it a sort of scatter gather list, right? And each bio vec looks a little bit like this, which are pointed to bv underscore page and the length of the page. So if we want to get a graphical representation, how it looks is that if there are a list of bios, and each bio would be pointing to a bio vec, and each bio vec would then again be pointing to different pages which are mapped to the virtual address of the buffer, right? So the bio layer starts with the submit IO function, right? It's a simple function which does a bit of accounting first. Let's first look into that. So it updates the PG in and PG out statistics for the virtual memory statistics type, and these are pages that are paged in and pages that are paged out. So these are pages read from the disk and written to the memory and vice versa. And if you look at the code, this is the piece of code which does it. And if you want to get the numbers from a live running Linux system, this is the command and this is how it should look. Right after this accounting, submit bio then calls submit underscore bio underscore no acct function. So the first thing this function does is checks if there is an active plug or not. We will discuss about plugging later in the MQ layer, but this is the first time we'll be getting a hint of this. Right now it doesn't do much, just updates a few things like a no await flags, but the main feature we would see what plug does and how it operates in the multi-queue layer, which will probably be in the second video. After this, it checks a number of things. So unwanted and unallowed bios are not sent further. So the checks here includes ones for flush, whether the underlying driver supports flush or not. Similarly, discard, secure, erase, and a number of checks for zone block devices. For example, whether zone append is only allowed when the IO is at the start of the sequential zone, whether bio is small enough and it does not cross zone boundaries, these kind of small checks. Once that is done, the function then calls submit underscore bio underscore no acct underscore no check. This is where we see the hint of the first major feature of the bio layer, which is recursion avoidance. Let's delve into that. So in this function, there are three distinct and separate paths which the bio can take, and this is that piece of code. The first one clearly checks whether the current running process has a bio underscore list defined. If it does, it just adds the current bio to that list and comes and returns from there. So this is the first part, which is done to avoid recursion, and we will see how that helps in the coming slides. So second part checks whether the device is request based or not. So if you see the second branch, if it second branch would be taken if the device is request based, and the last one would be taken if the device is bio based, right? And let's discuss about what bio based and request based devices are. Then we'll move further in the code flow. So sometimes what happens is device drivers want to skip the processing done in the multi-queue layer, right? Maybe they don't want scheduling to happen, they don't want the IO to go through different queues and fill waits. So in such cases, the block devices created are bio based, which means the IOs or the BIOS will skip the multi-queue layer completely and will be submitted to the device driver directly from the bio layer. For example, DRBD, distributed replicated block device, and BRD, the DRAM device, is an example of block-based devices which uses bio mode. While devices like null block can be configured to either use bio based mode or request based mode. So to create a bio based device different as compared to creating a request based device. In the gist, what you have to do is allocate a device using this function block underscore alloc underscore disk, and then assign struct block underscore device underscore operations to disk fops, and the structure should have dot submit bio function sets. Now let's look at request based block devices. For such devices, the IO passes through the multi-queue layer after the bio layer, which we'll discuss in the next video. And to create a request based block device, the steps are a little different as compared to bio based block devices. First, you'll have to initialize the block MQ tag set, and the above tag set should have struct block MQ ops structure set, which should have dot q underscore rq function set. And now using that block MQ tag, you should allocate disk using block MQ alloc disk, and this is how you'll get your request based device. So these two are different devices, and the bio or the IO would go through different paths based on it. For bio based block devices, the bio would get submitted to the device driver directly from the bio layer. For request based, it would go to the request multi-queue layer. Now let's get back to our code flow. So we were at this function and at this piece of code. So as we discussed, the last path is for bio based devices, and it ends up in the function underscore underscore submit underscore bio, which we'll see in the end. For request based devices, which is the else if branch, it would go through the function underscore underscore submit bio no count MQ function, which also eventually calls a submit bio function underscore underscore submit bio function. So these two are the parts that we're going to discuss a little while later, but we will focus right now on the first branch in this if else logic, which helps to avoid recursion in the bio layer. So let's see how the above function sets up and to prevent the recursion. So first, how does recursion occur, right? I mean, so there are cases or scenarios at times where virtual devices like MD or device mapper can use a stack of block devices, right? In that case, what happens is the IO would have to go through recursion with each time it is entering the bio layer, making small changes. So for different block devices that are stacked over each other, the bio would move through the bio layer of the first device then would move to the bio layer of the second device, while in each of those stacked bio layers there will be small incremental changes to the bio, and this is how it would look, right? Here in this diagram, bio 1, bio 2 are not different bios but are the same bios that has been changed a little bit because of this small change made when it enters a bio layer of the next block device stacked, right? So first it enters as bio 1, then it enters the bio layer of the second stacked block devices, and a little bit of change is made and it changes to bio 2, right? So to visualize this in your head, this bio layer here, for the bio layer, the bio IO is actually uh, coming through the same functions in a recursive way, but the devices are stacked on top of each other, right? And this is bad because yeah, this is bad because there's a long because of this, what's going to happen is there'll be a long list of stack calls, a function calls stack up to each other, and because of this recursion, which is going to take up a lot of resources, and if there's a file system above it, it's going to take up the resources even more. So there is a feature in the bio layer which is there to avoid this kind of recursion and reduce the resources used. Now, so this function that we were discussing previously has this following code, right? What it does is, if we take a closer look into this, what it does is it creates a bio underscore list as a local variable. Then what it's going to do is it's going to assign it to current bio list, which is the bio list of the currently running process, and then it's going to do submit underscore submit bio, right? And it's a do while loop, and once one of the submit bios gets completed, it's gonna pop the next one, and then one keep doing it until the bio list is empty. Now how it's gonna work is we're gonna see this in a diagrammatic representation next slide, but few things to keep in mind: that this bio underscore list is in stack and it will get freed once the function returns, and the list is not getting referenced is now getting referenced by the current, which is globally available to that process, right? So with the above code, the bio flow that we saw previously is going to change to this. So let's see what's happening here. First, what's happening is that the bio is coming as bio 1. In this function call, what it's going to see is there's no bio list to the current. So what it's going to do is it's going to create a bio list local and then assign it to current underscore bio, right? And when it goes to the second block device, which is the second call, the block layer, what it's going to see is there is already a current bio list uh, that is present there. So if you remember previously in the function, if there is a current bio underscore list, then it's just going to add to this list and return from there. And that is what exactly happens with bio 2. It sees the list, it adds to it and returns back. When it returns back, the do while loop that we just saw is going to pick that bio 2 from current bio list, and then going to process it. And once it processes, then it's going to become bio 3. So now what's happening is the bio is going through the same layers, but it's not going to be calling more than two bio layers in one go. It's going to go to the second one, add itself to the bio underscore list, return, and then process the list to which it added itself. So in this way, the recursion gets avoided. Right, so last function, as we had discussed previously, was the underscore submit bio function. And it is simple and it just calls to the next layer. But that also depends on whether your block device is bio based or request based. If it is bio based, it calls the disk fops bio function that the device driver had set while creating that block device. If it is request based, then is going to call block underscore mq underscore submit bio, which inserts the bio into the multi-queue layer, which we're gonna see in the next video. So I want to take this moment a little bit and try to recap what happens in this layer to the IO. The IO enters the bio layer with the submit bio function, and it does a little bit of accounting for updating the pages paged in and pages paged out. Then it's called a call into submit bio no account. The bigger function here is submit bio no account no check, which first checks if there's a bio list and then adds it to the bio list and just completely returns from there. This is the place where the recursion is avoided if this call is for the second block device in the second in the stacked block devices. If there's no current bio list, it's gonna go to request based, and the last one, if it's not request based, it's gonna go to bio based. There is a little bit of things happening in between, but both of them end up calling the same underscore underscore submit bio function. And in the underscore underscore submit bio function, the same decision is made. If it is a bio based, it calls the disk fops submit bio function, which directly enters into the device driver. If it is request based, it calls the block mq submit bio function, which inserts the bio into the multi-queue layer, which we're gonna see the path and the features of the multi-queue layer in the next video. So this is about us. We are a small non-profit group. If you have anything you want to ask or reach out, do write us an email. Follow us on LinkedIn and YouTube for more of these sessions and free videos. We're soon gonna be having a sort of a mentorship program for people who are interested in getting into the Linux kernel programming and device drivers. So we'll keep you guys posted. Follow us and wait for the news. Thank you.